One thing I've seen conflated a lot in technical discussions is people will talk a lot about reliability, and they'll talk about reliability and safety as though they're the same thing. But they're actually like often properties of a system that are at odds with each other. If you think about like your train or a subway or something, like a reliable train is one that's on time, but that train also has an emergency brake, and you'd rather the train be late than be in a ditch.
Welcome to the Reliability Rebels podcast, where we improve production by challenging the status quo. Your host, Amin Astaneh from Cherto Modo.
Check one, check two.
Reliability Rebels.
Check one, check two.
Reliability Rebels.
Check.
Reliability Rebels.
Welcome to the Reliability Rebels podcast, where we explore how to make software and systems more reliable by challenging the status quo. I'm your host, Amin Astaneh. Welcome to the first episode of 2025. To kick off the new year, let's discuss how technically challenging incidents can be and what it takes to remediate them. Not all production incidents are created equal. Some of them are straightforward, and all you have to do is check a dashboard and follow the runbook. But in some cases, clearly understanding what's going on and providing a solution will require all of your experience, all of your problem-solving skills, and a great deal of perseverance. Today's guest is Michael Abed, who I've personally worked with during my time at Meta. He is a very insightful software engineer who's capable of going deep into complex production systems and revealing key insights on how they perform and why they fail. He also considers human factors when it comes to building robust and safe systems, and has collaborated with me many times on how we do work as a team. Michael, welcome to the show.
Hi, Amin. Thanks for having me on. I'm excited to be here.
Yeah, again, thank you. This is amazing. So I know I gave you an introduction, talked you up quite a bit, but tell me a little bit in your words about yourself. Who are you?
Yeah, so I'm a software engineer who has worked a lot over the past like decade in like service management and infrastructure type areas. So I started out my career sort of working for my college's like IT department. I eventually got involved with supporting sort of like the research computing efforts there. I've also worked on things like server deployments for CDNs, and eventually sort of shifted into focusing more on like how do people like build and run their software. So working on things like API authentication platforms, service management platforms, and now I'm working on like continuous deployment systems. So yeah, really just been interested in making my coworkers like better able to like run the services and like run those well.
No wonder we got on so well when we worked at Meta. Yeah, a very common experience that you and I have is working at a university research computing department. Like, how was that experience? Did you rack and stack servers? Were you running compute clusters? Like, what was that?
Yeah, so that was a bit of it. That was a bit of everything. We had like various like high performance computing like clusters that we managed. These were all like pretty small scale in the grand scheme of things, but we had to deal with anything from like HP only sent us like the left server in their blade systems instead of like the left and right version, to like we've got professors who like can't print but insist on like only printing from the command line. So yeah, really ran the gamut.
Yeah, just for listeners, especially if you're, in high school or in early college, highly recommend, even if you're just doing 6 months, try to get into the research computing department and get a job there. You will learn so much, and that experience will definitely launch you into pretty amazing places when you look for full-time work. That's amazing, man. That's fantastic. Hilarious that we have a very similar background. So let's go even further back. How did you get into tech in the first place?
Yeah, so I mean, my interest in tech really picked up when I was in high school. Someone had suggested to me that I should learn Python, so like I started like reading a book about it and like picking that up. And sort of around the same time, my high school district ended up with some sort of grant to give every student a MacBook. And the funny thing was, like, most people just use those for like goofing off, and that's basically what I did with it as well. But I started to get motivated to like, okay, well, can I use this to like do some programming on, or can I use this to like run a game on? And these laptops were like really locked down. Like you couldn't go on YouTube, you couldn't run arbitrary applications. So if
Mhm.
you're a high schooler with really like nothing else to do, you start getting creative about how you're going to like get the thing that you want to do to work.
Mhm.
Um, so like I ended up like I could run the X11 app in Mac OS, which let you run Xterm. So I was like writing Java in Vim and like in this like horrible Xterm environment instead of like being able to use like a normal IDE. And at the same time, I was like researching like OS 10 exploits to like be able to like launch World of Warcraft so that I could like play a video game. I learned how to set up like dynamic DNS and use like SOCKS proxies to like access YouTube. So like that's really where like a lot of this like interest and like background knowledge sort of just started building.
That's like 0 to 60, from hey, I just want to run WoW to I am writing Java and Vim on my laptop in high school. That you're getting started pretty fast.
Yeah, well, I mean, like the being able to play WoW is a really strong motivator if you're a high school student. Like you'll read whatever esoteric documentation it takes to make that happen.
I can relate. What class did you play and what faction?
I mostly played on like private servers, but I played a warlock during like the Burning Crusade like patch time when the warlocks were like super overpowered.
How am I not surprised? That's awesome. Yeah, I was the crappiest hunter, blood elf on the Arthas realm. I was terrible at PvP, but I played a good number of years on World of Warcraft and think back to that time fondly. So again, interesting parallels. So all right, so that was how you got into tech. You're right. It's a very good incentive to be able to do things like play video games on your lockdown laptop, and you start learning things about your computer and your system that way.
Looking to scale your SaaS product or IT department without the usual headaches and costs? Check out Meadows' rapid assessment of production in depth. For a flat fee, you'll get a personalized, actionable roadmap to make your systems more scalable and reliable, all based on best practices from top tech companies and host Amin Astaneh's practical experience. Scale smarter, no extra hires needed. Learn more at chertomodo.io. Thanks for listening. Now, back to the show.
So where do you work at now? Let's talk about present day. You were at Meta with me, but what are you doing today? And what is this company?
So today I'm a software engineer at Datadog. I work on our release orchestration team. This is basically a lot of like our deployments infrastructure. So like continuous deployment systems, how the rest of the company ends up like actually like safely deploying and releasing their software changes.
Yeah, that's pretty important. I mean, if you have an incident, it affects the entire company. Organizations can't ship. So that's a lot of responsibility. It sounds like a lot of people depend on you.
Yeah, we take the like reliable running of like the deployment system pretty seriously. It's if it's down, it's hard for anything else to happen.
Yeah, so let's dig into this a little bit because it is interesting as far as you're able to divulge because of course you work for a company. But like, what processes do you have to ensure that you are making changes to your system safely, and how do you handle when things fail?
Yeah, so a big part of how we make sure that we're deploying things safely is, for one, we want to do gradual rollouts of our software. That's a big part of like what our software actually enables. So we use our own tools to roll this stuff out gradually. We've got certain guidelines for like what sorts of places certain software should get rolled out to in what sorts of order, and like how long should it be run in particular locations. But like a lot of the times, especially for systems like this that are maybe deployed in only like one or two places and are sort of like managing other things,
Mhm.
that kind of gradual deployment doesn't always work quite so well as like a bigger service or something that's like running everywhere, that can really take full advantage of like a like gradual software rollout. So for cases like that, like feature flags are really indispensable. Like I have I worked with those on my current team. I've worked with those in like several jobs. We worked with those extensively at Meta,
Mhm.
and really I think that those are a godsend because like they give you the opportunity to not just like gradually like roll out your software, but like roll it out on really fine-grained like verticals for like how do you want to enable this? Do you want to enable a feature for like just a particular organization or like just a particular like data center or just a particular like type of customer? You have a lot of control over how you're actually releasing stuff more than just like where your binary is running.
No, 100%. And there is something to be said about how easy and how quick feature flagging works in a system that is built to really benefit from it. Like when we were at Meta releasing changes to production, sure, we would ship new versions of our software, but we would hide it behind a feature flag. I remember moments where we would flip the feature flag, and within moments we would start to see problems, and then it's amazing to be able to turn the thing off and you know similarly recover quickly. I think that's the killer feature of feature flags is that it gives you the ability to limit the blast radius and duration of incidents.
Yeah, for sure. Yeah, I mean, I think like if you are looking into using feature flags, so like you want to make sure you're using something where the a change to a feature flag is visible very quickly to your application. You don't want to have to like restart your server like service process in order to like see that change. Because like with a feature flag, you can get a rollback within like seconds to minutes of noticing something, as opposed to like a like if you have a large service like deploying something and like landing a change in Git can take like d I've seen it take upwards of like an hour to actually like just like land a change, let alone deploy it. So being able to like quickly respond is key. And I know at Meta we actually had a really strict rule on our team with regards to like using feature flags. We tried to make it so that every single behavior change to our service went out behind a feature flag. Nothing
Yes.
was changed by through a binary release.
Yep. Yep. I think that type of behavior is what differentiated us from other groups as well as other companies. I think really mature organizations really do decouple the act of shipping new versions of software and the enablement and the disabling of features. And yes, we did have a very robust process around feature flagging, like everything had to be documented and you added them and removed them. You didn't allow feature flags to remain after you decided that that particular feature was going to be on all the time. A definitely killer feature. There are services out there that enable you to go and adopt feature flags today in your environment. You don't have to work for a gigantic megacorp to do it. I think Launch Darkly is one of those examples.
Yeah, I've used LaunchDarkly before. I found it really like straightforward to work with, and then like it had the like live feature shipping that I mentioned, and had a really like slick user interface in terms of like understanding like what's turned on in what environment.
Mm, absolutely. Yeah. Feature flagging. Listeners, if you haven't investigated it, I highly recommend looking into it. It might very well be a game changer in how you safely release features to production. All right, let's move on. So let's talk a bit more about automation. We've been talking a bit, in terms of feature flagging, that is a form of automation that enables us to build more robust and reliable services. But what role does automation play in general in how you build reliable systems, Michael?
Yeah, so I guess I've been the person sort of like building the automation systems that like other people tend to like use for their services.
Mhm.
Which I think for a lot of people, if you're just trying to like deploy a service, you definitely want to automate that. But if you're working on that infrastructure, one thing to think about is like, what do you need to have in place to feel like you actually can trust the infrastructure? So my a lot of my concern with regard to automation is like, how do you shut it off? How do you take back over manual control when your automations go awry? one thing I've seen conflated a lot in technical discussions is people will talk a lot about reliability, and they'll talk about reliability and safety as though they're the same thing. But they're actually like often properties of a system that are at odds with each other. If you think about like your train or a subway or something, like a reliable train is one that's on time, but that train also has an emergency brake, and you'd rather the train be late than be in a ditch. Designing things like break glass mechanisms or circuit breakers or ways of like safely shutting down automations is really important when you're thinking about like trusting those automations to actually be like running and taking like really potentially dangerous actions on your infrastructure.
Yes, that is huge. Sometimes reliability takes second place to safety. That certainly makes a lot of sense, and that goes back to the utility of things like feature flagging, because once you know that something is wrong, the time to implement the break glass is very short, which is really important when seconds matter. Now that makes a lot of sense. Were you involved in the break glass stuff at Meta for the service that we were responsible for?
Yeah, I put in some of those commands to like go and like shut down the platform quickly with like just running a command line program. It would go and basically update a particular feature flag that we checked that was like, is the system enabled at all? And that would shut down the system if you needed to in a hurry. I also worked on building some stuff to like detect when we thought that our platform was doing an anomalously large number of like delete operations to like take corrective action to stop it and get a human in the loop to be like, are we actually trying to delete that many things, or has a bug come up that is making us think that we need to delete that many things?
Yes, that does ring a bell. So to provide some context for listeners, Michael and I worked on an engineering team that provided an internal version of Heroku of sorts. And one of the biggest pieces of technology that we had was the mechanism that took customer configuration and intended state and applied it to the actual production systems that we were running on customers' behalf. And sometimes, depending on the inputs provided to that system from other services, you could have cascade failures if you're not too careful. So we had to put in a lot of safety mechanisms in place to prevent our systems from harming our customers due to something that we could not control.
Yeah. Another example of this that's been sort of in mind is if you think about some sort of like large distributed application like a CDN, imagine what would happen if there was a bug that let like someone on a website like use your CDN as like a DDoS vector. Like you probably want to shut down your whole CDN before you want to let an attacker use it as a very, very big weapon.
Yeah, huge. Again, sometimes safety is more important than reliability, and you have to turn the system off at moments. That's an interesting perspective. All right, so let's get into something really interesting. It's one of the reasons why I brought you onto the show. Tell me about the most memorable incident you've dealt with in your career. I had the privilege of being able to see this play out and see how you handled it.
Yeah, this one was a lot of fun. So this incident started off with our on-call getting paged for an SLO violation. We'd had a guy on our team spend a lot of time making these SLOs, and this was, I think, I don't know if it was the first time we got like a page for an SLO violation, but it was one of the earlier ones. And basically this SLO was that we had some critical API endpoints, and we wanted to make sure that those were performant. So we had an SLO for something like for response latency. We had a typical 95th percentile latency of like half a second on this particular API endpoint. So this alert fires saying that our 95th percentile latency is not what it should be. And we go and look at it, and it's like 5.5 seconds.
Right.
That's a little bit higher. The investigation of this sort of gradually expanded to start like pulling in other people in the team because like no one could quite figure out what was going on. people, before I got involved, people had tried a lot of different things and had identified a number of different symptoms and like things that were definitely not the problem.
Right.
So like there had been no new deployments to anything recently, right? Like we're running all the same versions of stuff. No one has turned on a particular feature flag. It's everything was running exactly as it was, and suddenly we have latency. At the same time, we didn't have any unusual like error rates or like elevated traffic volumes or anything that you would also think would like lead to breakages. People on our team tried a number of common remediation tactics, like they tried to restart our service processes. That fixed it for like 6 hours, and then it came back.
Right.
People tried scaling, like maybe we need more CPU, maybe we need more memory, maybe we need more instances. None of these had any effect. Still, like there was a process restart involved, so it would take 6 hours, and then it would those ones would also start exhibiting the same symptoms.
Right.
And one of the things that was getting really kind of annoying about this Sev was since it took about 6 hours to actually see the problem, it took about 6 hours to figure out if the thing you had tried had had any effect.
Right.
So we were trying to be very, very intentional about what we tried when. So you'd basically try something and then like leave it overnight and check it in the morning and like see like did that help anything?
I remember that. Yeah.
So by the time I got involved, there were 3 anomalies that seemed to be related to this latency spike. A few hours before the onset of symptoms, a unrelated endpoint on our service that did some data validation started basically giving a like error response saying that like the data that you're trying to validate is invalid. I guess that's like a successful response saying that your data is bad.
Yes.
So we surmised that somebody has like a script or is like running something that hits this endpoint twice a minute and has a bug or maybe. We identified a log message from a MySQL client referencing some sort of 5-second timeout. That was plausible for like what we were actually seeing because like that here's a 5-second timeout that wasn't there before the incident.
Yes.
But it was clearly not impacting like the success of our critical endpoint. It was just slowing it down for whatever reason. And finally, we were able to get like a process trace of like what was happening.
How did we do that? It wasn't plain old strace, was it?
No, this was like there's a Scuba table for traces.
Okay. Scuba is the observability, one of the observability tools that Meta has. The closest analog that you have out in the industry is Honeycomb.
Yeah, so we were able to find a trace of our process like exhibiting the symptom, and it showed the timeout happening in a like opaque like native library that was compiled into our service. This was a Python service, I should mention.
Yes.
So we've got this opaque library that also lines up with something related to MySQL because that would be in the native library. Something weird was happening with a MySQL client somehow, and it was happening in a way where for whatever reason, we think that this error that we're getting or this validation exception that we're throwing is somehow impacting other parts of our service.
Yeah.
In a weird way. And the other thing is that the onset of this like validation exception lined up with 6 hours before the onset of symptoms. So given that we know that it takes 6 hours for symptoms to show up, this traffic starting is probably the cause. And like this traffic was like really minuscule. It was again like 2 requests a minute.
It wasn't this huge spike that you can quickly identify in a graph.
So at about this point is when I got brought into the incident because people are like trying all sorts of different things, and we're expanding the like search party basically to see if anyone else can figure it out. So what I started trying to do is like, we think that this sort of traffic is related to what we're seeing. I'm going to see if I can reproduce this locally. And I was able to do that pretty quickly after just a little bit of trial and error, run a local copy of our service, send some like bad validation requests to one endpoint and then like send some other requests to our other endpoint and see what happens. This is all manual. I'm like interacting with things just like directly. Overall, not particularly like complicated to actually reproduce if you just do the things that we think were causing it, and it seems like they were. But that didn't really help us understand why this was happening. Just that like definitely this traffic is the cause of it.
We knew the what at least at this point when you very quickly
Yeah.
once you started.
Yeah, exactly. So at this point, I basically started commenting out half of the validation logic at a time. Like I'd comment out like the top half of the function and run it and see if I could reproduce it. And then if that didn't work, I'd like comment out the bottom half and see if I could reproduce it. Just to basically like binary search my way to like what is the line that like if what's the line that if I comment out is going to make this problem happen or not happen.
Clever. Yeah.
That it took a bit of time to do because like again I was testing all this like manually and have to like restart and recompile the thing, but overall not too difficult to manage. And eventually I found where we had in this validation routine like a list of particular validators, and I found that by enabling one of those validators or like disabling one of those validators I could no longer reproduce the issue.
Smoking gun.
Yeah. Except that validator is like not the validator that's like failing validation at all. It's validating something completely different about whatever the request is. But it was using MySQL. It was using a MySQL client to like query some stuff from an external database. This was still pretty weird. So zooming out a little bit, I was looking at how we were running this like list of validators. And one thing that we were doing was this service made very heavy use of Python's async.io library. And so all of these validators were like async functions, and this was using a helper function that basically just called async.io.gather to run all these different validators sort of in parallel or concurrently and get the results back and process them.
Yes.
We have this list of validator functions, and we are using async.io and async.io.gather. Zooming out slightly, this validator that we were running was in this list of validators that were all async functions, and we were using a helper function that basically did something like an async.io.gather to run all of these async functions at the same time and collect the results back. The problematic validator would basically connect to MySQL and like run a query and like return the results. Notably, the MySQL client that we were using had been augmented to support Python's async.io.
Aha. So your standard issue MySQL client is what
Not
you're saying.
not your standard issue MySQL client. Maybe that's your standard issue MySQL client today, but it was not at the time.
Fair enough.
This async.io.gather wrapper did have one notable difference from the bog standard Python async.io.gather, which is that if any of the functions it's trying to call fails, it will cancel all of the other tasks that it's waiting on. The typical way async.io.gather works is it just lets them all run, even if one of them fails. And this is something that can be kind of surprising, which is that Python async.io tasks are even cancelable. Specifically, if you call cancel on a task, it will, within that task, raise a cancellation exception or a cancellation error. So what would happen if you were to throw one of these cancellation errors into a MySQL client that was not expecting it?
Ooh. I mean, I wonder what would happen to the connection, right?
Yeah, so what could end up happening is basically the MySQL like wire protocol basically needs to track what mode it's in, whether it's sending or receiving data. And what could happen, I found, was that if you canceled a MySQL like statement execution while it was like sending data or while it was receiving data, you could get the connection to be in kind of a weird state.
Hmm.
And of course, we're using connection pooling pretty heavily to make sure that like we're not just establishing a new connection every time.
Right.
Um, so it turned out that what was happening with this connection is it was getting returned to the connection pool in a state where it's either like waiting for us to send it data or waiting for us to read data from it. But we no longer have any idea of like what state we're in with regard to that connection. So later, if something else in the process were to get that same connection, it would try to read this connection is like waiting for us to do a write, and like no one's progressing. And this is actually the timeout that we were seeing in the logs that I mentioned.
Right.
And so eventually, after discovering that, I was able to basically completely independently of our service write up like a proof of concept for like if you have a connection in this client that you cancel and you then try to use it again, you can see this like weird latency from the client. Having finally sort of like figured out like this is what's happening, I sent this proof of concept over to like our MySQL team to like be like, hey, this is weird. Can you look into if this is a real bug? And they were like,
Right.
yep, sure enough, that's a problem. And they were able to fix it, and we were able to like get our service fixed. Couple other interesting things I want to mention about this Sev. One was that we did investigate this log message from MySQL a little bit, and this ended up being that we found some docs about it that basically said that like, oh, if you're seeing this, it means that something's blocking your like Python like async IO event loop. You need to stop doing so much computation or don't call a blocking function.
Right.
This ended up being a complete red herring
Yeah.
in the investigation because I spent a lot of time basically trying to figure out how could any of this cause like this event loop to get blocked. So I wrote an event loop latency prober that would basically like put events in the event loop with like a timestamp and then like measure when they came off to see like what was the latency. And this showed absolutely no latency. Like nothing is taking time to process. Like the latency is close to zero. And the other thing that I think is worth calling out about this Sev was that this whole investigation took probably like 3 days of
It
like
did.
trying to figure out like what's going on.
Yeah.
But it was thankfully mitigated much faster than that because as soon as we knew that the traffic was actually the cause of the problem, someone on our team was able to go like figure out who was sending that traffic. And it was like a
Right.
guy running a script, and like we just like messaged him to be like, hey, can you stop doing that?
Yeah.
And
Knock it off, please.
yeah, yeah, please stop. And he did it. He's like, oh yeah, that has a bug. I've been meaning to go fix it. It's not even doing anything useful. It's like, cool, let's shut that off.
So that was the mitigation step, but
Yeah, that
you
was
were
the
following
mitigation.
you were following the actual like long-term fix.
Yeah.
Yeah. Wow. I really appreciate you sharing like the blow by blow. I know that we had this conversation in the past because I presented the incident to our department as part of our organizational sev review. So just as some context, one of the things that Meta does really well when it comes to incident management is that every major incident that a team has or a department has, we present that incident in something called sev review. And the whole point behind it is to learn from the incident and not just to identify the technical failure or bug or quote unquote root cause that triggered the incident, which in this case is the bug in the MySQL async IO, library, but also how breakdowns and how the incident was handled in terms of process. I remember, getting the full deets from Mike and then putting it in something that can easily be understandable by other teams and executives. And it was a really fun incident to present because of this crazy tale about what actually went wrong, which is the most esoteric thing I've ever seen.
Yeah, this one was a real challenge to like track down and figure out like what is actually happening. And I think one of the things that was surprising and really like slowed down the investigation was this like async IO like helper utility
Right.
that like hid the fact that this cancellation is happening. It's kind of made me feel like you should kind of just stick to whatever the language gives you for the most part, unless you've got a really strong reason to like go pull in a dependency. Um,
Yes. Yes. Though at large organizations like Meta, when you're dealing with ridiculous amounts of QPS, you sometimes have to go off-road a little bit in terms of the technology that you're using, hence why someone decided to go and write this library.
yeah, and I think part of this is kind of unrelated to what we've discussed, but I think that
Sure.
that this is something that we were even able to like debug in a reasonable fashion is kind of a credit to like having all of your source code in like a monorepo where you can just like trivially like step into Python MySQL library. If you're, just using the like off the shelf version, it can be a little bit daunting to like step into that code and be like, there's probably a problem in here. Uh, Whereas like when you're looking at that code and it's just like in another folder in your repo that like some other guy you work with wrote,
Yeah.
um, that's much easier to think like, okay, maybe there's something that's going wrong here. When
Yes.
like, whatever third party library you're pulling in, like maybe that's all really like super well vetted code, but also like maybe not.
Yeah.
Um,
There is something powerful about having a gigantic monorepo and bisecting the entire repo and figuring out what changed before and after an incident and being able to, as you mentioned, like find changes in a team's, code base that you are pulling in as a dependency. You have visibility into what the dependencies are doing in terms of changes and not just your own stuff. So that is a huge advantage over how people tend to do distributed systems, which is one repo per service. Cool. Yeah, I really appreciate you giving us the blow by blow. It is such a fascinating incident. It is probably one of the most technically challenging incidents that I remember. And yeah, like the whole team, they were all, taking cracks at it. I remember like SSHing into individual machines and running strace on, the process and trying to figure out what's going on from the system call level, because of course I have a bias towards, Linux and ops, but you were the one person who was able to thread the needle and get straight to the actual smoking gun and escalate the issue to the team and have it solved. So that is a huge feather in your cap, man.
yeah, this was a really fun one to like figure out, and I'm really happy I was able to get to the bottom of it. Like I feel like you a lot of the times you can run into these and you figure out some kind of like workaround or something, and you're like, I don't really know why that fixed it, but when you're able to really like dig into it and conclusively say like, no, this is exactly what's happening and this is why, and this is the reproduction script for like exactly how you can test if it's happening, is really satisfying.
Totally. No, it's a testament to you being dedicated to actually solving the problem. There are so many teams out there that are totally satisfied with saying, "Oh, I'm just gonna have a cron that kicks my service every 6 hours and call it a day and move on." But in this situation, we detected a regression in our latency metrics for this particular API endpoint from our SLO. It mattered to us to keep that value in a safe zone to be able to say that our customers are satisfied with the quality of service we're providing. All right, so we're coming up on wrap up. I again, an amazing story of how this incident unfolded and what you did to resolve it. So, tell us something outside of the world of tech, because we've been technical, this whole episode. Tell me about any books you're reading, any hobbies you're doing that's helping shape your approach to your career, but isn't necessarily related to it.
Yeah, let's see. So I can maybe give you an example of something that's maybe tech adjacent, and then maybe something that's completely outside of tech. Uh,
Sure.
But one of the things that has really shaped the way that I think about systems and shaped the way that I think about like how humans relate to systems is Nancy Leveson's book, Engineering a Safer World.
Hmm.
Uh, and this is a basically like a systems thinking approach towards safety. And
Cool.
like if you've ever if you're familiar with uh, thinking in systems, a primer,
I
which
know
is
that book. Yes.
which that's also one of if you haven't read, you should check out. It's maybe a easier intro into the field than Leveson's book, uh, but it's trying to look at the overall sort of like systemic relationships between like different parts of a system and like what their like control relationships are to each other,
Yes.
including modeling things like your operators and your operators like mental model for what they're doing and whatever your organization's like policies are and
Yes.
is part of like what's driving the behaviors of your systems. And it specifically seeks to find like given one of these system descriptions, find any way that like an undesirable state of that system could arise given like your model of it. Um, and just the way that it models things as like control loops with like hierarchy,
Hmm.
and that way of thinking about the relationships between things has been incredibly helpful for me in terms of figuring out like what are we missing in our systems, or like what are we overlooking? Where where are our feedback channels actually in terms of understanding like who's going to learn about things when? How do our automated systems have a feedback channel to be able to respond to some of the things that we want them to respond to? And then I've also found that a safety lens is actually a much like broader lens than you might think,
Hmm.
because like if you zoom out a little bit, like safety is really just preventing things that you don't want to have happen.
Right.
Um, like safety could be a, I don't know, part of your like customer retention strategy if you think about it that way.
Sure.
Infosec can be thought of as 100% a safety field. Um,
Absolutely.
yeah, so that one has been, I think, hugely influential in just how I've thought about systems.
Hmm.
Um, outside of tech, there is a YouTube channel I've been a fan of for a while that is focused on like car engine teardowns, uh,
Cool.
and specifically like ones that have failed.
Yeah.
Um, and that's really interesting because it's kind of like a mechanical sev review in a sense.
Sure.
Um, and it's you don't pay like full attention. It's just kind of on in the background. But like
Yeah.
the takeaway again and again is just like maintenance and like how do we make time for preventative maintenance to like keep things running in the context of tech. That's like, okay, well, if we know that we have to like kick this thing every 6 hours, like we do need to actually go and like fix that. Otherwise, we've just like, we've ignored the problem. We've not done our like maintenance. We haven't fixed it. Our thing is still broken.
Right.
Um, or like, you've got whatever your like incident review task backlog that's, probably just like growing. You do the review and you put the task on the queue, and it stays on the queue. You've got a list of a whole bunch of stuff that you should do. So like making sure that you have processes in place that actually like get those tickets addressed in any kind of like timely fashion. That's one where I feel like it's coming back around to like the like systems lens on things is like you need to think about like what is your engineering team incentivized to actually do, and how do you, if your sev tasks or incident tasks are like separate from like your normal prioritized work, like why, like you have no expectation that those are going to get done. So like that needs to somehow be part of like your process in a way that isn't just like off to the side.
100%. You're upstaging me, man. This is the stuff I usually talk about, and you're talking about it. No, that's awesome. It's true. 100% true. I love the preventative maintenance metaphor because you're absolutely right. Like when we're driving a vehicle, it's like, yeah, you change your oil every 5,000 miles, you rotate your tires, same frequency, and you do these things. And if you do that, your vehicle will run properly. But it's like we throw that principle out the window when it comes to software for some reason, and then we get surprised every time there's an incident.
Yeah, well, and I think it's ultimately that like in a lot of organizations, the people that are like responsible for like setting priorities aren't necessarily the people that are responsible for like actually like getting things like delivered and built. So like I know like a lot of engineers will really want to prioritize like fixing things and doing maintenance and understanding that like that's actually like what's enabling us to be able to like have like the velocity and have the time to do these other things that are really important for like sort of continuing the business.
Heck yeah, speak my language, man. I couldn't have said it better. So to wrap up, one last question: how can people reach you?
Yeah, so if you want to reach me, you can reach out. My email is michaelabed@gmail.com. I'm not really active on any like social media or anything, so don't expect to find me there, but feel free to reach out by email.
Awesome. Thank you. Michael, a pleasure having you on. Again, it's been an amazing discussion drilling into one of the most challenging incidents I have ever seen in my career. And it was a joy to see you just like systematically go through it and address it. It was just an awesome thing to witness. Thanks for joining us.
Yeah, thanks again for having me on. It's been a pleasure.
Thank you for listening to today's edition of Reliability Rebels. Until next time.
Check one, check two.
Reliability Rebels.
Check one, check two.
Reliability Rebels.
Check, 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 check.
Reliability Rebels.